Section 2.2 is quadratic functions. You should be familiar with f of x equals ax squared plus bx plus c. It's the graph of a parabola. The vertex, we find the x value by using negative b over 2a, and then to find the y value, all this means is that we are going to find the y that goes with it. This is function notation, so whatever this number is, I take f of that number. In other words, plug that number in to get my y value. So the only thing new here is the function notation for the y term of the vertex. If a is positive, the graph opens up. If a is negative, it opens down. And our vertex or our axis of symmetry are both found at negative b over 2a. Take a minute to write this down. I'm going to just move ahead, so pause the video if you need. Standard form or vertex form looks like this. The other form was called the general form. This is our hk shift again, so the vertex is at hk. The axis of symmetry is at h, the vertex x value. A causes it to shrink or stretch, and if a is less than 0, we get a flip. This is all the transformation stuff we've been working on. To graph from standard or vertex form, we're going to check first to see if the graph opens up or down. We're going to plot that hk value, plot some x-intercepts, in other words, set the equation equal to 0, and find out what the x-intercepts are. Plot the y-intercept by substituting 0 for x, and then if you need some additional points, go ahead, but you should be pretty good with that point. Okay, so let's take a look at one of these. This is going to open down, because a is negative. My vertex is at negative 1, negative 2. So I'm going to plot my vertex and make it be at negative 1, negative 2. And it is opening down. So if it opens down and my vertex is here, there really shouldn't be any x-intercepts. I can double check by setting this equal to 0. I should get 2 equals negative 2, x plus 1, squared. Divide by negative 2, and take the square root, and we can see right here that my x-intercepts are imaginary values. The y-intercept, if I find f of 0, it will be negative 2 times 0 plus 1 squared minus 2. That's going to be negative 2 minus 2, or minus 4. 2, 3, 4. And then to get another point, I would probably look for a point of symmetry, maybe plug in f of negative 2, and I will get negative 4 for that as well. So there's my parabola. The things that we're going to be looking at here, in particular this section, are maximum and minimum values. For a quadratic equation, these always occur at the vertex. We have a maximum if the function opens down, and a minimum if the function opens up. So again, looking at an example, this is going to open down, so we should be able to find a maximum at the vertex. Now, since this is in general form, I'm going to find the vertex by doing negative b over 2a, happens to be 1, and then if I find f of 1, in other words, plug in the x value to get my y value, I will say that the vertex is negative 3 plus 6 minus 13, and that would be negative 10. So at the point 1, negative 10, and I'm running out of room here, but at the point 1, negative 10, I should have a maximum. It opens down, so my graph will go this way. So my maximum value, the highest point on this graph, is negative 10. Where does that maximum occur? It occurs at x equals 1. So we say there is a maximum value of negative 10 at the place where x equals 1. We can also tell domain and range from this. For quadratics, domain is always all real numbers. And in this case, our range will be that y has to be less than or equal to negative 10. So we can get a lot of information from this maximum and minimum values. Now I want you to look in your textbook on page 293, and there's an example at the bottom that talks about a punted football, and they give us a nice equation, f of x equals negative 0.01x squared plus 1.18x plus 2. It's an open down path. We can see that it is punted at a y-intercept of 2, so it's 2 feet off the ground when it touches the punter's foot, and we want to see the maximum height of the football. Take a moment and look at the next page and see if you can see what they do to get maximum height. Okay, so you can see that they begin by taking our negative b over 2a. I'm looking at the top of 294, and they get a maximum height of 59 feet. Oh, excuse me. At 59 feet, that's my x value, we get our maximum value. They then plug that back in, and they get a height of 36.81 feet. So the maximum height of the football is 36.18. It occurs 59 feet away from the punter. So we can find max and mins by doing this. Take a look at the bottom of 295, and they show you the steps to go through to find a max or min. What I'd like you to do now is to look at example 6 on your own, turn off the video, and look at example 7 on your own. Turn off the video and come back when you're ready. Try doing them without looking at the solutions. Okay, sorry about that. All right, so the first problem, product. We have two values, x and y, and we want to maximize the product of those two. So, oh, excuse me. I'll try this again. Can't get my pen to work. Okay, so the product is x times y. And we know that their difference is 10. So x minus y is 10. We want to maximize the product of x times y. So I'd like to write this all in terms of x. Well, y, if I solve this for y, I find that y equals negative 10 plus x. So I can just plug that in. I will get a quadratic here. It opens up. So I've got x squared minus 10x. And I should be able to then work on finding, the minimum product. This will open up, so I need to find a minimum product. I'm going to find that at the vertex. The vertex here is negative b over 2a. So the minimum occurs at x equals 5, and if I plug that back in, the minimum value is 5 squared minus 50, which is negative 25. So this is actually underneath, and the minimum product would be negative 25. The area problem that I asked you to look at, they gave us some information about perimeter. So the perimeter is 100, and I want to find out some information about the area. So again, since I want to maximize area, I'm going to take the given information and plug it into here. So solving for y, divide everything by 2. So y equals 50 minus x. So my area is going to be x times 50 minus x. That's negative x squared plus 50x. So this is an opens down parabola. I should be able to find a maximum area for a particular value of x. So you should be able to finish that up on your own, find the x value that goes with this, and then plug in to find y, and y will give me my maximum area. If you have further questions about these examples, we'll talk about them in class. And that's it.